Welcome back to World Decoder. We explored the billion-dollar bodies of chips, but today we must find their missing soul. We possess the physical bodies, those billion-dollar chips from ASML and Zeiss. Yet without software, they remain just lifeless silicon. Without the magic of code, that expensive pile of processed silicon is essentially just organized sand, waiting for a command. Today we decode the most powerful force controlling the digital world, the invisible layers of operating systems and source code. This is the story of how humanity taught cold metal how to think, transforming electricity into logic and artificial intelligence. Imagine the chip as a massive army of billions of soldiers, powerful but completely unable to understand any human language. These soldiers do not speak English or Vietnamese. They only understand two simple states of existence. On is 1, off is 0. Software acts as the great general. It translates your complex human desires into the simple binary language of the hardware. When you tap an app icon, you are sending a high-level command that must be broken down into billions of actions. The software converts your simple touch into a torrent of zeros and ones, instructing the transistor army to march instantly. This brings us to source code, the master rulebook containing every instruction needed to control the behavior of the machine. Programmers write these rulebooks, crafting the logic that defines how the hardware should react to every possible user interaction. But how does your phone play music, download photos, and receive notifications all at once without crashing into total chaos? Enter the operating system, the great butler of the digital world. You know them as Android, Windows, or iOS. The operating system acts as the resource manager, deciding exactly how much brain power the chip should dedicate to each task. It decides which application gets access to the memory and which one must wait, ensuring the system remains stable and fluid. Without this manager, applications would fight violently for control of the chip, causing the entire device to crash immediately. When the operating system fails to manage these conflicts, we witness the dreaded freeze, or the blue screen of death. But when it works, the operating system is an invisible conductor, creating a symphony of logic that feels like magic. Programmers write software using languages like Python or C++, which look somewhat similar to human language structure. However, the chip cannot read these words. It does not know what a loop is or what a variable means. This is where the compiler enters. It is a high-speed translator machine that bridges the gap between human and silicon. The compiler scans millions of lines of human-written code and translates them into machine code, an endless string of zeros. The magic lies in efficiency. It must translate the instructions to be as concise as possible for the chip to execute. A poor compiler will make a powerful 3nm chip run slowly, wasting the incredible potential of modern hardware engineering. Now let us discuss a fascinating concept called firmware. This is software that does not live on your hard drive. Firmware resides directly inside the chip or component. It is the permanent software that acts as the hardware's basic instinct. Just as an animal has instincts at birth, firmware helps the hardware know what it is the moment it receives electricity. When you press the power button, firmware is the very first thing to wake up and arouse the other sleeping components. It performs a roll call, ensuring every part of the system is functional before handing control over to the operating system. Why is software so incredibly expensive and difficult to produce? Many believe code is free because it is physically invisible. Modern operating systems like Windows contain up to 100 million lines of code. Printed out, it would reach the sky. Managing this colossal amount of logic is a feat of engineering that rivals the construction of the most complex physical cities. The margin for error is 0. A single misplaced comma among 100 million lines can cause the entire system to fail. Finding a single bug is like searching for one specific red grain of sand inside a massive, endless white desert. Engineers spend thousands of hours hunting these invisible errors, a process that requires patience, logic, and immense dedication to detail. Then there is the challenge of compatibility. The software must run perfectly on thousands of different types of hardware configurations. It is a massive optimization effort to ensure that the code adapts seamlessly to whatever hardware environment it encounters. We must understand this fundamental truth. Hardware is the body, but software is the mind that gives it true purpose. A world without software is a world that stands still. The most advanced chips are useless metal without lines of code. As we move into the future, we are seeing artificial intelligence begin to GDK its own software, accelerating this evolution. The cycle of innovation continues, with software pushing hardware to its limits, and hardware demanding more powerful software in return. Every time you swipe your phone or use a computer, remember the millions of lines of code working silently for you. We have decoded the soul of the machine. It is a masterpiece of logic, language, and human ingenuity woven together. If you enjoyed this journey into the mind of the machine, please like this video and subscribe to our channel. Next time, we might explore the invisible network that connects these minds together. The cloud is waiting to be decoded. Thank you for watching World Decoder. Keep questioning the world around you, and we will see you in the next episode. Remember, in a world built on silicon and code, understanding the technology means understanding the future of our human civilization. From the early days of punch cards to the cloud era, the language of machines has evolved into an art form. There is a hidden beauty in algorithms, a mathematical elegance that brings order to the chaos of the information age. Millions of developers around the world collaborate, sharing their code to build the foundation of knowledge for all of humanity. Software also serves as our shield. Cybersecurity protocols protect our most private data from those who wish to steal it. Through updates, software allows our devices to learn new tricks and improve themselves long after they have left the factory. In hospitals, software analyzes medical scans with superhuman precision, helping doctors save lives and detect diseases earlier than ever before. In space exploration, software calculates trajectories and controls rockets, allowing us to land precisely on distant planets and moons. On our roads, software is learning to drive, processing visual data to make split-second decisions that ensure our safety. Software is even entering the realm of art, generating music and paintings, blurring the line between calculation and creativity. We are approaching the horizon of artificial general intelligence, where software may one day understand the world better than we do. This power brings responsibility. We must ensure that the code we write reflects our best values and ethical standards. The programmers of tomorrow will not just write code. They will be the architects of new virtual realities and experiences. As technology advances, software becomes more invisible, weaving itself seamlessly into the fabric of our daily lives and homes. The Internet of Things connects everyday objects, allowing your refrigerator to talk to your car through the language of code. The speed of this evolution is breathtaking. What was impossible yesterday becomes the standard today, thanks to software innovation. Understanding the logic of software is becoming a fundamental skill, as essential as reading and writing in the modern era. We rely on these systems for connection, information, and entertainment. Our modern society is built upon a foundation of code. Good software is resilient. It learns from attacks and failures, adapting to become stronger and more secure over time. The best software respects the hardware. It uses energy efficiently, prolonging the life of the battery and the device itself. Binary is the new universal language. It crosses borders and cultures, connecting humanity through a shared digital infrastructure. Let us celebrate the silent heroes, the developers who stay awake to ensure our digital world keeps spinning without interruption. The responsiveness of a touchscreen is a marvel of software engineering, predicting your intent before your finger even lifts. Software allows us to process big data, turning mountains of raw information into actionable insights that change our world. The cloud is not magic. It is simply someone else's computer managed by incredibly complex software to serve you data. Quantum computing will require entirely new kinds of software, rewriting the rules of logic that we have used for decades. Software preserves our history. It digitizes our collective memory, ensuring that human knowledge survives beyond the lifespan of paper. Can software ever truly feel? We are teaching machines to recognize and simulate emotions, bringing them closer to us. The ultimate goal of software is simplicity. It hides the immense complexity so that you can focus on your life. Behind every video we make, there is also software helping us edit, render, and distribute these stories to you. What software do you think has changed the world the most? Let us know in the comment section down below. From firmware to operating systems, we have seen that the invisible code is just as important as the visible machine. We live in a connected world, woven together by the silent, tireless work of billions of lines of executing code. World Decoder is committed to unraveling these mysteries. We break down the complexities so you can understand the future. Thank you for watching World Decoder. Subscribe now to continue unveiling the hidden layers of our complex technological world. Goodbye.